Okay, today we're going to continue on with taking double displacement reactions a little bit further. And we're going to talk about those that make a precipitant. Okay, so when you have a double displacement reaction, you might have a precipitant as a product. And a precipitant means you have solids that form, and so those solids are insoluble, so you will put an S after their formula. So when two ionic compounds dissolve in water, so they're going to be aqueous since they're in water, their ions may react with one another to form a precipitant. So here are your solubility rules. So all common compounds of group 1A, so this is the 1A metal, so it's talking about this family here, and ammonium ions, which is NH4+, are soluble, so they would be AQ. All nitrates, acetates, and chlorates are soluble. So since they're soluble, that would be AQ. All binary compounds of halogens other than fluorine with metals are soluble, except silver, mercury 1, and lead 2. So that simply means if silver is with your halogen, it would be insoluble, or mercury 1. All sulfates, which are your SO4s, are soluble, except if you put them with barium, strontium, calcium, lead 2, and mercury 1. So if any of these are with your sulfate now, they're insoluble, so they would be an S. Except for rule 1. So rule 1 means your 1A metal and ammoniums, all of your carbonates, hydroxides, oxides, silicates, and phosphates are insoluble. So the only way these guys are soluble is if you put them with a 1A metal or ammonia. Sulfides are insoluble except for rule 1, and then calcium, barium, strontium, and magnesium. All right, so the first thing you're going to do, so it says, write the chemical equation for sodium hydroxide, aqueous, and copper 2 chloride. Okay, so you're going to write formulas correctly. Every time you write anybody in this type of reactions, you have to give their state of matter. Okay, and then if it's charges, if it's got charges, make sure you show your charge. All right, so your chemical equation, let's see if I've got enough room here, would be sodium hydroxide, and it should be right here, but I'm going to put it up here so I have more room to write. Sodium hydroxide is NaOH, plus copper 2 chloride, so the copper 2 chloride would be CuCl, that Roman numeral 2 is copper charge, 2AQ, yields, okay, so it's double displacement, so Cu will go with OH, and Cu has a 2 plus charge, so that would be CuOH2 plus Na will go with Cl. Okay, so your reactants are always going to be AQ because you're mixing two solutions. Your products, you will go to your solubility rules to see if they form a solid or not. You could have two AQs over here, then no reaction would occur, or you could have one precipitant form and one AQ, okay? So let's look at NaCl. So Na is a 1A metal, so you already know that any compound with a 1A metal in it they are going to be soluble, so NaCl will be AQ, okay? So that means we need to look for copper hydroxide, copper 2 hydroxide, and so most of the time you're going to look at your poly, not necessarily, but so just go up here and you find hydroxides, and it tells you here your hydroxides are insoluble. That means they're an S, unless you put them with a 1A metal or ammonia. Copper is not a 1A metal, so this compound will be an S. So like if you mix sodium hydroxide and copper 2 chloride, you will get a precipitant, and it's going to be CuOH2. Now don't forget to balance. So you have 2 chlorines here, so you're going to put a 2 here. That gives you 2 sodiums, so you're going to put a 2 here. Okay, you have 2 hydroxides, 2 hydroxides. Now you're balanced. Okay, so that's your chemical equation. So next you'll do your complete ionic equation. So substances that are ions in solution are written as ions in the equation. Okay, so we're simply going to take everybody that has AQ behind them. We're going to break them up into their ions, the correct number and the correct charge. And then on the product side, if it's AQ, you'll break it up into ions. If it's an S, you will not. Okay, so we have 2 Na plus AQ plus 2OH minus AQ, okay, plus Cu, its charge is 2 plus AQ, plus you have 2 chlorine ions, so you're going to say 2Cl minus AQ. Do not leave that as Cl2. Yields. Okay, on the product side, if it has an S behind it, you will not break it up. It's going to make your precipitant. So you're going to say CuOH2 solid. And then if it's AQ, you'll break it apart. So you have 2Na plus AQ plus 2Cl minus AQ. Okay? Now, just like when you go to a ball game, the spectators are those people that should stay in the stand and not get involved. So spectator ions are those that appear on both sides. So they're an ion on both sides. Therefore, they're not involved in the reaction. So what you want to do is you go through and mark out all your spectators. So if it's an ion over here and it's an ion over here, you can mark it out. So you have 2Na plus AQ, 2Na plus AQ. It's a spectator. You have 2OH minus. You don't have it as an ion over here as part of a compound. Do not mark it out. The same for Cu. You have 2Cl minus, that marks out. Okay, so then your spectators will not appear in your net ionic equation. So you simply bring this all down, and I would, if I were you, I'd always write my positive ion first, even though this one appears first in the formula. Okay, so it's going to be Cu2 plus AQ plus 2OH minus AQ will yield, CuOH2 solid. All right? Okay, so our next one. So you're going to label, so you're going to have your chemical equation, your complete ionic equation, and then your net ionic equation. So you have aqueous solutions of potassium iodide and silver nitrate. So make sure you have your solubility rules where you can see them. So potassium iodide is Ki, and it's aqueous. Your reactants are always aqueous in these. Silver nitrate is AgNO3. Nitrate, remember if it's an 8 or iod, it's a poly, +1 -1, AQ. Double displacement, so your products are going to be KNO3 and AgI. Always write your metal first. All right, so now you go to your solubility rules. So remember, all of your 1A metals are soluble, so K is a 1A metal. So this, since it's soluble, that's AQ. Okay, now we're going to look at silver iodide. So it tells you here that your halogens are going to be soluble except if you put them with silver, mercury 1, or lead 2. Well, this is silver, so that means this is not going to be soluble. It's going to be insoluble, so it's an S. Okay, so remember for your CIE, you will break everybody that's AQ up into its correct number of ions and correct charge. So you have K plus AQ plus I minus AQ plus Ag plus AQ plus NO3 minus AQ yields. Once again, on your product side, you only break apart those with AQ. So you say K plus AQ plus NO3 minus AQ plus. This is your solid. Do not break it apart. AgI solid. Okay, so for your NIE, you go through, you find all of yours that are ions on both sides. Those are your spectators. You mark them out. So K plus is an ion on both sides. Mark out. I minus is an ion here. It is not here. Do not mark it out. The same for silver. NO3 is an ion here, an ion here. So what's left over, you bring down to write your NIE. Once again, I would always write my positive guy first. So Ag plus AQ plus I minus AQ will yield AgI solid. Okay? If you want to put me on pause, then you can join me back. Okay, ammonium phosphate. So ammonium is NH4. Phosphate is PO4. 1 plus 3 minus. So we're going to do this. Okay, AQ plus sodium sulfate, NaSO4. 1 plus 2 minus. Crisscross, that's Na2. AQ, it gets kind of, okay, so now you're going to put Na with PO4, NaPO4, plus 1, 3 minus, so it's going to be that, plus NH4 is going to go with SO4, 1 plus 2 minus, we're going to put that in parentheses. Okay, so we're going to go to our solubility rules to see our product. So Na is a 1A metal. All right, so it is soluble, so you're going to put an AQ after it. And NH4 is ammonia, so it's also soluble. All righty, so this is your CE. Now let's balance. I forgot to say that up here, but we were balanced. So we have 3 NH4, so we're going to put, and we have 2 here, so we're going to put a 3 here. We're going to put a 2 here. That gives us 2 phosphates, so we're going to put a 2 here. That gives us 6 sodium, so we're going to put a 3 here. And now we have 3 sulfates, 3 sulfates. So if you've written everybody correctly, it should be pretty easy to balance. All right, so let me just show you something. So everybody that's AQ is going to be written as 9. So you're going to say you have 2 times 3 is you have 6NH4 plus AQ plus you have 2 PO4s, 2 PO4, 3 minus AQ. You've got to show, when you break them up, you got to put them the correct number and their charge, plus 3 times 2 is 6 Na plus AQ, plus you have 3 SO4s, 2 minus AQ, yields. Everybody over here is AQ, so you're going to say 6 Na plus AQ plus 2 PO4, 3 minus AQ plus 6 NH4 plus AQ plus 3 SO4, 2 minus AQ, okay? And your charges should balance your numbers of ions. If they don't, you've done something wrong. So look here, everybody. So you have 6NH4 plus, 6NH4 plus cancels. So 2 PO4, 3 minus, 2 PO4, 3 minus. 6 Na plus, 6 Na plus, 3 SO4, 3 SO4. So all of these were spectators. So after you write this, you don't have to necessarily go through this step. You can go, well, since these are both AQ, your NIE, you would simply say, 2 NH4, 3 PO4 AQ plus 3 Na2SO4 AQ, and you're just going to say no reaction. But don't get carried away with that because you don't have that many of those, especially on your homework. All right, so that's it. So that lets you now do your homework set that goes along with precipitation reactions.